Floating fun. What makes things float? Have you ever looked at a rubber duck bobbing in your bathtub or a massive ship gliding across the ocean and wondered, why do these things float? Have you ever wondered why a giant ship can float on water, but a tiny pebble sinks right to the bottom? It seems like a mystery, but there's a fascinating explanation behind it. It's all about something called buoyancy. Buoyancy is a scientific principle that explains why some objects float while others sink. Buoyancy is a force that pushes things upward in liquids like water. Imagine it as an invisible hand that lifts objects from below, counteracting the force that pulls them down. Think of it like an invisible hand pushing up on objects from below. This invisible hand is what keeps things like boats and rubber duckies afloat. Some things, like boats and rubber duckies, have more buoyancy than others. This means they have a stronger upward push compared to the force pulling them down. This means the upward push is stronger than the force pulling them down. That's gravity. Gravity is the force that pulls everything towards the center of the Earth. When buoyancy is stronger than gravity, things float. For example, a boat floats because its shape and the air inside it make it less dense than water. The water pushes up on the boat with a force equal to the weight of the water displaced by the boat. This upward force, or buoyancy, is what keeps the boat afloat. On the other hand, a pebble sinks because it is denser than water. The force of gravity pulling it down is stronger than the buoyant force pushing it up. So next time you see something floating, remember it's all about the balance between buoyancy and gravity. Dive in, exploring why things sink. Now, imagine that pebble again. Why does it sink? Some objects are heavier than the water they push aside. Gravity pulls harder on these objects than the buoyancy force pushes up. It's like the pebble wants to go down more than the water wants to hold it up, so down it goes, sinking. Buoyancy, the upward push. Let's talk more about this amazing force called buoyancy. When something goes into water, the water pushes back. It's true. The water level rises a bit, right? That's because the object is taking up space where the water used to be. The water pushes back on the object with an upward force. That force is buoyancy.
A long time ago in the ancient city of Syracuse, a really smart guy named Archimedes figured out something incredible about buoyancy. Archimedes was not just any scholar. He was a mathematician, physicist, engineer, and astronomer. His contributions to science and mathematics are still celebrated today. Legend has it that he was taking a bath and noticed the water level rising as he got in. This simple observation led to a groundbreaking realization. As he watched the water rise, he began to understand the relationship between the volume of water displaced and the object submerged in it. He was so excited by this discovery that he jumped out of the tub and yelled, "Eureka!" Imagine the scene, a brilliant mind, dripping wet, running through the streets of Syracuse, shouting in pure joy. This moment of sudden insight is what we now call a eureka moment. The word eureka means, "I have found it," in Greek. This exclamation has since become synonymous with moments of sudden, profound discovery. What Archimedes found was Archimedes' principle, which explains how buoyancy works. This principle states that an object submerged in a fluid experiences an upward force equal to the weight of the fluid displaced by the object.
A bathtub eureka moment. This principle has vast applications, from designing ships and submarines to understanding the behavior of various objects in different fluids. Archimedes' principle is a fundamental concept that helps us understand why things float or sink. It is crucial in fields like engineering, physics, and even medicine. For instance, it helps in calculating the buoyancy of ships, ensuring they can carry heavy loads without sinking. It's pretty amazing, don't you think? The story of Archimedes and his eureka moment reminds us that sometimes the most profound discoveries can come from the simplest observations. So next time you take a bath, remember Archimedes and his incredible insight into the world of buoyancy. Section 5. Density, the float or sink factor. In this section, we will explore the fascinating concept of density and how it determines whether an object will float or sink in water. Understanding density is crucial in various scientific and practical applications, from designing ships to understanding natural phenomena.
Archimedes' principle tells us that buoyancy depends on how much water an object displaces, or pushes aside, and the weight of that water. When an object is placed in water, it pushes water out of the way. The amount of water displaced is directly related to the volume of the object. If the weight of the water displaced is greater than the weight of the object will float. Conversely, if the weight of the water displaced is less than the weight of the object will sink.
This is where density comes in. Density is a measure of how much mass is contained in a given volume. It is calculated by dividing the mass of an object by its volume. The denser an object, the more mass it has in a given space. This concept helps us understand why some objects float while others sink. Density is how much stuff is packed into a certain space. For example, if you have two objects of the same size but one is heavier, the heavier one is denser. Scientists use various tools and methods to measure the density of objects, including scales to measure mass and graduated cylinders to measure volume.
Think of a big fluffy beach ball and a bowling ball the same size. Even though they are the same size, they behave very differently in water. The beach ball is full of air, so it's not very dense. Air has a much lower density compared to water, which is why the beach ball floats easily on the surface of the water. The bowling ball is packed with heavy material, making it very dense. The materials inside the bowling ball have a much higher density than water, causing it to sink quickly when placed in water.
Objects less dense than water float, and objects denser than water sink. This principle is not only applicable to everyday objects, but also to various natural and engineered systems. For instance, icebergs float in the ocean because ice is less dense than liquid water. Similarly, ships are designed with hollow hulls to ensure they displace enough water to stay afloat. Understanding density and buoyancy is essential in fields like engineering, environmental science, and even culinary arts, where chefs use the concept to create dishes with different textures and densities. Section 6: Boats, Floating Giants.
How can massive ships made of heavy metal float? It's all about shape and density.
Ships are designed to displace a huge amount of water.
Even though they are heavy, the weight of the water they push aside is even heavier. Plus, the shape of a ship's hull, the bottom part, helps it displace even more water, increasing the buoyant force.
Section 7: Icebergs. Tip of the iceberg. Have you heard the expression tip of the iceberg? It means only a small part of something is visible. Icebergs are a perfect example. Ice is less dense than water, so it floats. But only about 10% of an iceberg is above the waterline. The rest is hidden below, displacing a huge amount of water to keep the iceberg afloat. Section 8: Fishy Fun, Swim Bladders, and Buoyancy. Fish are buoyancy experts. They have a special organ called a swim bladder that helps them control their depth in the water. The swim bladder is like an internal balloon.
Fish can adjust the amount of gas in their swim bladders. Adding gas makes them less dense and helps them float up. Releasing gas makes them denser and allows them to sink lower.
Section 9: Fun fact time, floating on air. Did you know that buoyancy doesn't just happen in water? It happens in air too. Hot air balloons float because the hot air inside the balloon is less dense than the cooler air surrounding it. The buoyant force of the air pushes the balloon upward, just like water pushes up on a boat. Section 10: Why buoyancy matters. Understanding buoyancy is important for so many reasons. It helps us design ships that can carry heavy cargo across oceans. It helps us understand how fish and other marine animals survive in their watery homes. It even helps us explore the skies with hot air balloons. So, the next time you see something floating, think about the amazing force of buoyancy at work.